A broken bug zapper. It doesn't light, it doesn't zap, doesn't do anything. Let's see why. Plastic base doesn't do us anything. Looks like the lid is held on by ordinary Phillips screws. Little teeny ones into plastic. It's kind of a cheap thing. Normally these things have a high voltage circuit for the zapping and a black light of some sort, fluorescent in this case, to attract the bugs. Let's see what this one has. The lid off. There's not a whole lot in here. I expected to see a couple of these boxy devices, one ballast for the fluorescent lamp and one for the high voltage supply, but I just see one of them with 4 leads. Got a board with half dozen diodes, some capacitors, might be a voltage multiplier or something, and what looks like a fluorescent starter that's just a globe. Usually they're enclosed and they have a little filter capacitor, but this one appears to be cost optimized. Let's see if we can figure out what the circuit board is doing for us and what the mysterious lump is when I expected 2 lumps. The diodes are connected in series and simply come from the red leads of the transformer. So it's not a voltage multiplier or anything, it's just to get a little more voltage out of the diodes. They're just using 3 instead of just 1. And the output of the diodes are filtered by the capacitors and go via these leads to the zappy grids. And the other winding appears to be the ballast. So this is an unusual combination device that the current flowing through it to operate the fluorescent bulb creates a magnetic field that both limits itself the way inductors do and induces another field in another winding which creates the high voltage for the zapper. So it's cost effective. Instead of 2 cores and 3 windings, there's 1 core and 2 windings, but it's a specialty part. I wouldn't even know where to get one of these if it broke. I'd probably end up replacing it with a separate ballast and high voltage transformer if I bothered at all. But there's no apparent reason why this doesn't work. So let's plug it in and see what happens. Well, the starter glows. That's encouraging. So what that is a timed switch where the gas discharge heats up a bimetallic element that eventually moves over and shorts against the other electrode. That warms up the heaters in the fluorescent lamp, and then since it's not glowing anymore, it should open it up and that'll start the fluorescent lamp, because the inductor that's also the ballast will generate a high voltage pulse when it's disconnected, and that should fire the bulb. If it doesn't, the cycle just repeats until it does. It appears, however, that starter, while it's glowing happily, isn't really completing the cycle and doing something. So I'm going to see if I can encourage it by doing it manually. So I'm just going to short across the leads as if the switch closed. Do that briefly, long enough for the heaters to warm up and then open it and see what happens. Oh, that worked. So it appears the problem is fairly simple. It's just the starter. Problem is, it's not a standard starter that snaps into a socket, so I can't just grab one off a shelf. But this little globe here is what's inside a standard starter. So I think the next step is to find a standard starter, pull the globe out, and replace this one with it. So I'm going to go ahead and unplug it and let the capacitors discharge while I look for a starter. Okay, I found some candidate starters we can use. Starters aren't all the same. Different ones are used for different size bulbs, and they have a strange little code. And this bulb is probably in the order of 8 to 15 watts. It's a medium-sized bulb. It's about a foot long and U-shaped. So let's see what we have. This one's an FS2. It's good for 14 to 20 watts. This one's also an FS2, so it's good for 15 to 20 watts. This is a COP 40, which I've never heard of. I guess it's for 40 watt. And these are more FS2s. And I'm just going to pick a victim, take the insides out, and replace that globe with the one from inside the starter. So the aluminum ones are easy enough to open. You just bend the tabs back. This one has a plastic housing. So there we are. As you can see, there's not a whole lot in here. I'm going to go ahead and warm up the soldering iron since this one is soldered in. Now clip this starter capsule out of the mechanism. The other part's a capacitor. Not a very good one. It just pulled off its own electrodes. That's really kind of sad. These things are pretty cost optimized. So at least it'll be a good match for the rest of this circuit. Make sure the capacitors are discharged. Yeah, no volts there. These wires don't look like they really want to take solder, so I'm going to clean them up a little bit. The process of embedding them in the glass tends to oxidize them, which is in fact what they want, because copper oxide is soluble in glass and actually makes everything work better. Okay, I had to pause there briefly because I got a phone call. So now we can continue. And connect up this little starter. I'm just tinning the leads so it'll be easier to solder when we get to the board. make sure that they will take solder. Otherwise I would have to prepare them further. Not taking solder happily, but it looks like they're doing so. And to remove the old one. Oh, it doesn't want to come out. That's one lead. And the other. Let's clean those up just a little bit. See if we can get the replacement one in there. Doesn't look quite alike, but I think it'll do the job. See if we can get that lead to go in just a little more happily. Yeah, that looks better. Add a little fresh solder to get a more reliable connection. I don't know if you noticed it moved when I heated the other one, which tells me this one is not connected at all. Let's try that. That seems better. Shall we give it a try and see if it lights automatically like it's supposed to? Well, that was exciting, but it powered up, so I'm going to call that fixed. Now all I have to do is put it back together. And there isn't a whole lot to it. Give it a quick tap to make sure the capacitors are all discharged. Seems good. That's what these resistors are for. Just wanted to make sure they had time to do their job before I put my fingers on everything. I think I chose the wrong hole because that one just doesn't want to grab. There were just the two screws in it. I guess it's nice to have spare holes if the original ones strip out. There we go. I was lying down some, so I'll have this one lie down a little bit. The lid thread doesn't seem to have a particular sightedness. So I'll just put it on in any direction where the screw holes line up. Turn off soldering iron. I think we're done with it. Making sure these things line up properly. Sometimes they don't want to. It also has this two-part plastic base it sits in. I suppose this is the insect catching tray. And this, I'm not sure how this connects. It's not obvious. May not be important, may not even go to this. So, one last try now that it's buttoned up. Yeah, comes right up. Good to go. Thanks for watching. Talk to you soon.